Hey everyone, this will give people another minute to join. All right, let's go ahead and get started. People can join as they come. So today, actually, I think none of the chairs could attend last meeting. It looks like most of the topic was taken up by Usama. Do we? And there was another topic for Mark's verifier governance document review. Any other topics we want to hit today? No? Okay. Mark, I put your agenda item first. If you're ready, we can start to review that. If you see people here you want to wait for, we can come back to it.
I think we can go.
Okay, great.
Do you mind sharing the screen, or do you want me to pull it up? I didn't know I was going first.
Yeah, yeah, if you could pull it up, that'd be great.
The attestation governance pattern, right?
Yep.
Okay, or verifier governance pattern, rather. Okay, just give me 1 second here. Okay. I suspect I will need to zoom in. Let me know if you don't see it, and I can.
Looks good for me.
All right.
Maybe a little bit bigger, but
No problem. All right, so to level set, governance patterns are written in what's called the patterns language. And if you don't know what that is, I'm going to, my browser just froze, so give me a second here. Wait, can you hear me?
yeah, I can hear you.
Okay. My browser, see, it's like really not responding to me for whatever reason. What about that? Oh, no. Why? What's going on here? Maybe if I, yeah, my browser just froze on me. Chrome is not being my friend. Okay, let me try launching another instance. Oh, it's really screwed. Okay, well, we need to kill my browser here. Sorry about that. Blame Google. Yeah, it does. Okay, you may need to pull it up. I'm unfortunately, I don't want to delay everyone. I can't even see. I can't even get to them. launch another instance of the browser. Oh, did it come back to life? No. Yeah, I'm so sorry.
Yeah, that looks like I had to request access, so I don't have, can't share it unless you got the request.
Hmm. Oh, no, it came to its senses. Okay,
Okay, great, thanks.
right. So, okay. So first of all, patterns are written in the patterns language. And I'm going to double click on this folder. If you want to learn about what the patterns language is, I'm going to put the link to the chat. Again, feel free to request access. I'll grant access to anyone who wants. It's a kind of a formal method for putting patterns. And the pattern has several sections. So there is a context. So basically, if you find yourself in the following situation, you may have a problem. And the problem is the thing you're trying to address with the pattern. Forces is what makes the problem difficult to solve. The solution basically talks about what it is you do to address the problem. And then we have our own expectation summary section, which is not part of the pattern language, but it refers to another pattern we have, which is the ecosystem participants and what they expect of each other. And then there are certain languages, clarifications, and references. So the context here is you cannot do confidential computing without this trusted verifier component. And the document basically covers the governance requirements inherent in operating a trusting a verifier. And again, as all governance documents, they are written in a manner that is as technology agnostic as possible. Clearly, we cannot be completely technology agnostic here because we're talking about confidential computing when we're talking about verifiers, but trying to draw the line or making as verifier agnostic as possible. So the problem here is that we have the linchpin of content computing is the verifier. If that thing is somehow not trustworthy, then you cannot trust anything else about confidential computing. And this is why we need to figure out exactly how to ensure through governance that we are, we can trust this entity. And again, this is sort of part of the overall OSI stack of governance. There are separate documents explaining what governance is. It's effectively a mechanism for knowing the state of your system, having expectations to your system, having levers to move your system in the direction from where it is to where you want it to be, measuring the progress, reporting the results, and kind of repeating the loop. Again, anyone who is not familiar with that, feel free to shoot me a message and I will share all that background information with you. So forces, let's go through them real quick. And by the way, let me put this document in the chat as well. So you can have it here. I will monitor my email here in another window for anyone who requests access. So I can, as soon as you send me a request, I'll get an email and I'll be able to. So Greg, for instance, if I see an email from you. Oh, James, sorry, James, I just saw the a request from you and grant it. Why am I doing it? It's supposed to put up a request. All right, so availability and performance, right? So if your verifier goes down or is slow, you're going to have a problem. So through governance, you may want to address things. Again, we talk about things like noisy neighbor, or but it's effectively if your verifier goes down, your compute goes down with it. And we talk about ways of ensuring through governance that you have sufficient availability and sufficient performance. Then we're talking about confidentiality and integrity as is applied to certain assets. So we have policies, we have secrets. We need to ensure that the policies are, have integrity. A particular enterprise may also require that policies have secrecy. So, for instance, if I know that you are going to attest a vulnerable workload as being within your policy, I may be able to use that as an attack vector. So while not an ideal prevention mechanism, that may be a requirement. So then we talk about confidentiality of evidence and attestation results, because again, the RATS architecture calls for it. Then we talk about this other thing that, again, a lot of engineers who are not in the trenches of governance do not know this concept, that there is a system of record. A system of record is the authoritative repository of information about the state of the system, the history of the system, the policies inside the system. So we will care about things like the history of the verifiers, as well as the present state, the history of policies, perhaps the history of signing keys, maybe the history of attestation results, right? So all of these requirements that an auditor might have to your verifier would be listed under system of records. And now the next section is solution. We use the standard IETF must, should, may delineations. And so here's,
Mark,
yes,
I have a question before you go to the solution.
yes, of course,
So is this a correct problem statement that you want to ensure that the verifier is trustworthy? Is this a
correct.
correct problem statement of what you are trying to achieve?
So much like with confidential computing generally, right? Confidential computing doesn't say that trustworthy code is running. It just says that the code that's running cannot lie about the state it's in. This is very much the same way. So here we will say that the verifier may not be trustworthy, but at least it will not be able to lie to you about the state it's in. Right, so that would be the requirement. Now, hopefully, by not being able to lie about the state it's in, it creates an incentive for it to become trustworthy. So, for instance, the governance is not about ensuring that you have a correct policy in place. It is about ensuring that if somebody went and put in an incorrect policy or like did some sort of a downgrade or whatnot, that you are not going to be able to, perhaps the administrator of the verifier is not going to be able to lie about the policies that the verifier is enforcing. I hope that makes it clear.
So basically, what I was trying to understand was there is a difference between the verifier code being correct versus the verifier code being as expected. I think you mean the latter and not the first one.
Correct.
Okay, so in that case, basically, you need something to verify that verifier, right?
Uh, Well, I think that's a really an excellent consideration, that we're not just verifying the policies of the verifier is enforcing or the keys that it's protecting or using, but we also may have some governance requirements around verifier running the code that we wish for it to run. I do not think we say that explicitly, but I think it's a great let me just add a comment here. I do not know if it's the right section, but just note to self.
The reason I was asking was basically the way I view it is basically attestation by itself does only ensure you that the right code, I'm not sure if right code is even the right word. I mean, that the expected code is running, that's all attestation gives you. And you mentioned formal in the beginning, so I was just curious that basically the other thing, which is that the code itself is correct. I mean, the expected code could itself just leak out the keys and that's it.
Mhm.
So your game is over, right? So
Yeah,
it's only checking against some measurements, which, and it's not saying that these measurements are really correct. They could be that the code itself might be a huge VM code and it might have vulnerabilities inside, and it could
yeah,
be A trivial way to break it is that even a small piece of enclave just leaking out the key, so measurements will still match, but the thing is broken. So I think we need to distinguish between expected code and correct code, and attestation only gives you the former and not the later. For the later, you need to formally verify that piece of code meets your requirement or is
Yeah, I
as
think
expected.
we mostly mean expected, and so yes,
Okay.
I think that's a great input. We will go back and see how we can rephrase this. So thanks for catching it. I would probably go and see because like there is sort of prior art to everything, and in this case, I would go and see what it is that we do in cases of like key management services, because there are similar considerations apply. Like you want to make sure that the key management service runs expected code in some way, shape, or form, and so the governance requirements should not be drastically different between the two classes of quote unquote appliances. David, I see you have your hand up.
So we've had a discussion about this in the past, and there's been an implication that the verifier itself, the code there, would be open in some fashion, that you could
Mhm.
verify the validity of the code itself, not just verifying that the code you're expecting is running inside the verifier, but that you can, and obviously not everyone would do this, but I believe someone from Microsoft in the past had mentioned that their plan was to make the code for their verifier available.
Yeah. Yeah,
Um,
and I also
but
add to
there is a
that.
transparency issue here, right? Like
You're correct.
it's
Yeah.
the same issue with any proprietary software, right? If the verifier is completely proprietary, you can have a measurement all you want, and that hash means nothing,
Yes,
which is going
and
to the conversation here.
another mantra I try to remind developers of is good code running in bad configuration will do bad things. So there is the code issue, and then there is also the configuration issue, and this is why I added another note here that perhaps we should be talking about. Well, and by the way, whether verifier needs to be open source or not, that for a regulated institution, this is a question of risk acceptance, right? So at a bank, for instance, we can say $100 million of fraud a day is probably not a problem if you're doing 4 trillion in transactions, or like, the number may seem large, but not compared to, say, the overall volume. So likewise, we may say, well, perhaps AWS isn't really truly confidential computing, but we will accept the risk because we trust the provider. So there is kind of a dial in addition to here saying that, we are putting a set of configurations or a set of considerations in front of you, like institution and the auditor, that we believe would be, good for you to consider. Now, if you decide between you and the auditor that a certain level of risk acceptance is fine, then it's not the goal of this document to convince you otherwise.
But I think I kind of fully agree with David. I think in the past I have multiple times left over this comment about the open source. Even if you trust that auditor, I think it needs to be explicitly mentioned that either you have it open source or you explicitly trust an auditor in order to do some audit, or you agree with that. That is, if that is not open source, you trust somebody in order to achieve that kind of guarantee that you still need. I think that
And
point
you
really
may,
needs to be.
the organizational policy may say, we trust Amazon. Like it's not for us to dictate. So here we can outline a set of considerations. We can basically say, if you
That's
want to govern it, if you want to done it well, here are our best recommendations. If you choose to ignore them, and between you and your auditor, you're fine with this, or maybe you have other ways of ensuring correctness, then it's not up to this body to dictate otherwise.
Yes, but it should be clear that if they choose to trust Amazon, that's not confidential computing. That should be clear. So you are writing this document for confidential computing on behalf of Confidential Computing Consortium, and I would say that's not a good choice to leave it open and claim to people that they choose to trust Amazon, and then they still claim that based on this governance document, we claim that we have confidential computing.
Fair enough, fair enough. And this is where, if you scroll down, we have, a consideration, usually a should. For every should that we will say, we have a little bullet point here to say, this is what happens if you go against this should. This is the risk you're exposing yourself to. So in here, I may say you should audit the code of the verifier. And then there will be a bullet point down there basically saying, if you choose not to go with this recommendation, this is the risk you would need to accept. And that would normally be how you navigate this particular scenario.
I think that's fine, but you definitely have to make that distinction clear in the document.
I agree, and this is where I'm basically thanking you for the input, and we just added the the verbiage specifically to that effect.
And to be fair, there's a lot of places in confidential compute where we are implicitly trusting the vendor or whoever, right? No one's going to open source 100% of the firmware for whatever device that they're going to be running in a confidential compute environment, right?
Right.
So there is some implicit trust, and like you said, you have to do your risk management appropriately and make sure that you're willing to accept certain risks. But this one seems like a pretty low-hanging fruit on where we can get people either, as you said, through a third-party verified audit of closed source code, or using an open source verifier like Verisum, to have the transparency here that gives better trust in the system. And maybe that's one of your shoulds in the list down below. You should make their either the source code available publicly or to some trusted third-party auditor that can issue a certificate of quality on the verifier.
Right. So this is what I'm going to do. So tomorrow morning at 7 a.m. Pacific, where the GRC SIG meeting will take place, and I will take this feedback into the GRC SIG meeting if you would like to join and go deeper into sort of what's behind these comments. We will discuss it there. We will make the changes and we will bring them back to this body. So let's move forward. So we just talked about the verifier code. That's all great. So so availability, performance, confidentiality, integrity. Now we're also talking about the integrity of the code of the verifier. We will add some language to that. And we talked about system of records considerations. That's very, very important to any thing that has a history of things that may impact policy-driven decisions. All right.
Sorry, so can you,
yes,
Mark, can you clarify what do you mean by confidentiality? Confidentiality of what exactly? Is it
confidentiality would be, so you definitely, if you manage keys, and as a verifier might have keys, right, to sign results of attestation, for instance, right, that would require confidentiality. If it has policies, that requires integrity. Policies may also require confidentiality depending on the risk tolerance of the customer of the verifier. Right, so they may say, well, we may attest vulnerable workloads, as I said, but we don't necessarily want to make that fact widely known, right? And that would be solved by making sure that we don't broadly advertise what our policies are. Not something I recommend, but something that happens.
But what you write at the end of the document, the last line is saying confidentiality of evidence and attestation results. And to me, it's not clear, why do you need the confidentiality? That should be integrity protected by a attestation key.
So privacy, that's for the privacy configurations. So a comment was made previously in this review that where we talk about specifically evidence and attestation results. If we don't make those confidential, we may have privacy issues. This is not about the policies of the verifier. That's separate. That's a separate asset, right? For privacy of the attester, we may want to make those, and this is because RATS calls it out, right? And that's why it's here. So that's why I kind of reluctant to revisit that one. But there is a separate issue of confidentiality of the verifier policies. That's not a privacy issue.
Mark, can I ask a question? Whether the confidentiality you're talking about, is it transport confidentiality or is end-to-end confidentiality?
So we're talking about, in this case, when we talk about confidentiality and integrity, we're talking about assets and under the protection of the verifier. And those assets are keys that the verifier might use for like signing and policies as far as trusted root stores or the actual verifier policies or the reference values. And you know, we don't worry about what happens. So, say somebody went and messed with your reference values. Well, that's an integrity violation that can have bad downstream consequences.
Okay.
So here I make a distinction between assets, which is something that is part of the verifier state, so keys, policies, things like that, and inputs and outputs. That would be evidence and attestation results, because those are not right.
I'm concerned about inputs and outputs rather than the assets, which I understand better, because as Usama said, that might be okay. Taking care of this as a requirement is good, is excellent, but there are different ways to achieve the privacy goal here. So, for example, you could have selective disclosures of privacy impacting claims, right? That your attestation result format could support.
Yeah.
You know, blinding out some of the PII things and keeping the rest clear text, for example, but integrity protected, of course, by the key that's.
So here I put should, and I remember how I said for every should, we're going to have a bullet that explains what happens if you don't honor that should. We will put that under there.
Okay. Okay, cool.
Mm-hmm. Yeah, these are sort of legalese documents at this point, so it's good that we're giving it this level of attention. I'm by no means pushing back on any of it. I'm, you know, just trying to steer it towards this is what we're going to have and why. Okay, so let's go into solutions now. And again, you can read for yourself what we discussed here. Verifier governance aims to achieve the goals. So for high availability, should be maintained. And then we talk about different mechanisms for doing that. Throttling, quotas, you know, over provisioning, replication, concurrency, all of that. Then we talk about protecting verifier assets, policies and cryptographic keys, and evidence and attestation results. So this is, again, we talk about confidentiality, integrity, etc. I don't want to read what you can read for yourself. So any comments you have here, that would be you know, good to hear. Oh, by the way, we already have a should on confidentiality protections for evidence and attestation results. So I remember that in here, I don't use capitalized shoulds because these are just, these are not, this is not a normative section, the forces. The solution section is normative. So yeah, we're already covering this. See? So notice that we're not specifying how you're going to protect, say, integrity of the history. Like I could be saying blockchain, but that's kind of technology specific. So we're not going that far. Like somebody may decide how they want to do that. Maybe they have an append-only store maintained some other way, like we do, for instance, for like email retention, right? So for instance, if you want to make sure that your emails are retained, then anytime an email goes through the system, it gets sent literally to another organization for storage, which is read-only append storage. And the, you know, for instance, we might be using some vault, you know, hosted by IBM, where the bank, we, you know, at that point on completely lose ability to modify that after the fact. And if there is ever a subpoena for, you know, someone's records, it's in that vault. So it doesn't have to be, say, blockchain. So that's why careful not to specify the exact mechanism by which something should be achieved.
Quick question or clarification. So where do the protocols lie? So we need, I think what Thomas was also previously pointing to was one thing is that you protect evidence or attestation results, like kind of the RFC 9334, kind of these artifacts of that picture. The other thing is, how do you incorporate protocols on top of that? I understand that you do not want to point to some specific technologies, let's say attested TLS or attested this or attested noise or things like that. But at least there should be something which is saying that the protocols used are secure. So I don't see that in the solution anywhere. Is it somewhere upside or down, or is it not included at all? If not, then
I
why?
am inclined to say that it's not included at all and it is implied. So
I
for
would say
instance,
it should be.
when I say, for instance, let me explain. So when I say confidentiality of evidence and attestation results, and we say you should maintain it. Well, normally the way you would maintain it is you receive evidence over a secure transport and you deliver attestation results over a secure transport. But it need not be said here. Because again, so long as you convince your auditor that you maintain confidentiality of that thing somehow, maybe you used one-time pad. I'm not saying you should. That's not up to this document to specify the mechanisms.
Although, Mark, there's a substantial difference between object security and transport security, I think. And if this applies to transport security, we should really say, you know, because this sort of models the attacker, right? So it subsumes a certain kind of attacker. So if the attacker is someone that snoops on the channel, is one thing. You are okay with transport security. If the attacker can attack the end node, a different thing, right? You need object security because you
So,
want to.
okay, so then let's think about the threat model and let's consider an attester presenting attestation evidence and receiving attestation results. There are multiple ways in which confidentiality of these things could be breached. One is that the attester node itself is compromised. Another one is the transport between the attester and the verifier is compromised. The third one is that the station result is sent over secure transport to a secure attester, but at the same time written into clear into some log, right? It's not up to this document to also be the threat model. The threat model is subject of an individual verifier implementation that, you know, you are told keep this thing confidential. And it's entirely up to you how you're going to do this. Like if we go down the line of completely threat modeling every hypothetical that might happen, this document will balloon, will actually be less useful
Okay, I
in a
understand.
way.
I understand.
Is is the can the whole that whole space be circumnavigated by in this doc essentially saying, you know, the verifier's endpoint to do verification must, must or should or whatever the right verb, be a secure channel to the caller. And that implies, it's everywhere, then you can just say the verifier needs to keep this stuff, confidential if that's a requirement. And then you don't have to get involved in any discussions outside because it just has one endpoint, right? That's like, give me the attestation evidence. Here's your attestation results. If that channel's secure and if on my side I keep everything confidential, kind of game over for this whole topic, I think, as far as
So for
verifier.
all I am concerned, if the verifier talks to the attester over plain text channel inside a steel box with an armed guard, then the confidentiality of that configuration is fine. Right? We're not mandating a mode of implementation.
Some could interpret secure that as being consistent with a term like secure channel. In a box.
Well, but this is like I would like to keep us out of having to think about every possible variant.
But so it's your doc and you understand the
Well,
scope.
it's our doc. It's our doc. I'm just giving you my reasoning.
Well, if the scope is about where does the scope start and end, right? If the scope here is about the service provided by a verifier, then it starts when the request, when the data comes in, and it ends when the results come out. And then, so thinking about things like the attester communicating the attestation results to the relying party, which has the verifier is not involved in, is obviously not in scope for what's happening here. And so that's not even on the radar for, being discussed. So I don't, know what the scope.
So let's
doesn't- yeah.
let's say you have a valuable and you take it to a bank and you say, I would like to put this valuable inside a safety deposit box. And then you basically tell the bank, here's a thing, I'll pay you some money, you keep this thing safe for me. From that point on, you don't really necessarily care what it is the bank did to keep it safe. You don't go examine the vault. You don't go maybe you're hoping that there is some regulator there that enforces some rules, and then some auditor goes and makes sure that the bank does the right thing. But it is very rare that you're going to be examining whether it's to your satisfaction. There is sort of a level of indirection here. You say,
So what
you
so-
state
so-
the expectation, you hope that the bank will satisfy it.
So, Mark, the example that you are giving is very naive. So, the first thing is whether you are going to the right bank. That's the first thing. I think creating that secure channel is giving you that guarantee that you are really connecting to that bank, or you are, in your example, you are really going to the right bank and you are not going to someone who is going to steal that thing. And I disagree with your comment that you made that you want it to be high level. And I think what Thomas was also explaining is that's very high level thing that you want to ensure that it's network security and endpoint security. That's the endpoint security is what I think Thomas was calling object. But the point is that the network security and endpoint security, these are two very high level abstract things. So that's not really going down to the threat model of everything. You can say that at least the secure channel between these entities, attester and the verifier and the relying party, these secure channels exist without having to specify the technology, whether it's done via noise, whether it's done via, let's say, TLS, whether it's done via ad hoc, it doesn't matter at all. But at least that secure channel should be established. The authentication property should be satisfied. You should ensure that you are really talking to a bank and not somebody else. So that's what is actually missing. I don't see authentication being mentioned at all in the whole document.
Yeah, I hear you. I hear you. I guess I am trying to figure out, because the argument that you just made can be made arbitrarily deep, right? You say, well, we want a secure channel between the verifier and the tester. Well, we also want to ensure that there is, endpoint security on the verifier and endpoint security on the tester. Who is to say, where do you draw the line? And I'm saying that the high level consideration is confidentiality, which is broadly interpreted as need to know access to a particular piece of data.
I don't think
And
confidentiality.
how that need to know access is enforced, that is going to be done in a myriad different ways.
I don't think confidentiality, the point I'm making is that confidentiality by itself does not guarantee that it was a secure channel and you are connecting to the right party that you wanted to connect to. So
Well,
that's
if you
network security.
interpret confidentiality as need to know access has been somehow enforced, then you don't need to say anything else.
But confidentiality by itself doesn't include authentication. It's a separate property. It has nothing to do, you could have, okay, simple example. You could have confidentiality of evidence as you write in 2C. You could have confidentiality of evidence. You could have confidentiality of attestation results, but still mess up with the authentication property. That's what I'm trying to say. that you could be connecting to not the intended verifier, but rather some other verifier, or in your example, like you
Yeah,
are.
and then an auditor can look at it and say, because the the auditor would come in and say, based on just what's written here, in your environment, your attester did not authenticate your verifier. And because of that, the attester sent the evidence to the wrong place. And because of that, the confidentiality property of the evidence has not been met.
But that's a very vague way of reasoning. I think that's
It's actually very precise, because either your auditor says, yes, you maintain this confidentiality, or the auditor says you haven't and gives you an explanation, and then you have to go fix it. That's actually how it works today.
so.
Like
Are
the
you still
requirements are
talking?
specified as a fairly high level set, and then the auditor will look at. I'll give you another example of like the sort of thing you deal with in real life. Regulations say you should document the longest amount of time that an unpatched workload can be in production. Okay, so that's all it says. And then we will say, we'll do not have a single workload in production running continuously that has a known vulnerability for more than 2 weeks. And then we say, in 2 weeks, we're going to take this workload and repave it with the exact same workload, but it's not continuously in production. Now, to you and I, that kind of sounds silly, but so long as the auditor signs off on it, we're golden. This is like, it has to leave a significant amount of room for interpretation. And then people who practice it better end up having a better product, but it's not the job of this body to over-constrain.
Yeah, but Mark, you have to understand that you are not in the governance SIG, you are currently in the attestation SIG. And like
Well, the
for
output
us,
will be consumed by people who do governance.
that's fine. But what I'm saying is technically that's incorrect. So confidentiality does not guarantee you authentication. It's a separate property, technically speaking. So whatever your audience is, it might be fine for them, but of course, we will tell you to make it more explicit, because that's technically speaking, it's a different property. It's completely orthogonal to that. As I have tried to convince you, like you could have confidentiality without having authentication. And you talked about formalism in the beginning. I don't think this document is formal in any way, but we have a formal proof which says that we have the authentication property was not satisfied, but the confidentiality of the keys was still satisfied. You had the keys confidential, but still the authentication property, you were not connecting to the right party that you wanted to connect to. So it's a
But I don't
completely
think you heard
orthogonal.
me. I don't think you heard me say that if I didn't authenticate my endpoint and I sent my evidence to the wrong place, to the auditor, that will be, you violated your confidentiality protection that was expected of you. And that would force the body, like, that deployed the verifier to make sure that the tester would attest the verifier. We don't need to go and specify every security property, only the outcome.
They are two independent things. I don't think you can try to relate it to that. You will be missing many attacks which are possible, and we have shown that. That's all I would say.
Right. I mean, so where do you stop? A tester received attestation results and ended up writing them in the plain text into the log. Should we be specifying to do that as well? Right. I mean, that's not what's expected by people who do governance. Now, I also see a couple of other hands up. So
Yeah.
David.
So I guess the question is, how actionable do you want this document to be, right? Because if you look at like PCI compliance, they have high level requirements like protect all network traffic with strong cryptography during transmission over a public network. That is a very, very abstract concept. Though that can be broken down into multiple security controls, they can be implemented multiple ways. And that is very high level, but is still a concrete, actionable requirement. Just like provide confidentiality is not an actionable requirement. Because as you said, someone may interpret that as guns, guards, and dogs between a server somewhere. But in reality, us who practice, security architecture and stuff like this in the real world know that providing confidentiality on any network facing service means you have to provide network encryption over public networks. There's no
This
other
is-
option for that, right?
This is
And
how
so-
you interpret it with your auditor.
But-
And that's perfectly fine. This may
so
be the
then it's not
99%
actionable.
case.
Then this isn't an actionable document. If it's whatever the auditor says, then there's no purpose in having a document that says what you should do. Unless you have something that's actionable in the document that an auditor can point at and say, this is the requirement, you are not meeting the requirement.
Let me give you
what is the
another.
point of having a document?
Let me give you another example that perhaps clarifies this. So, for instance, when we operate in multiple jurisdictions and we have things having to do with, let's say, keys and ciphers and like rules around that, and we will say a communication over a channel must be protected using an approved cipher with an approved key length of the right length. And what approved means will actually mean very different things to an American auditor, to a Chinese auditor, to a Russian auditor.
But that's a more concrete statement than what you have here, that confidentiality should be protected, right? That is, use the appropriate protections for your jurisdiction in terms of ciphers and key length to protect the network data that's being transported between point A and point B. That's a concrete statement. That's not, we need to ensure that the connection is confidential, right? And that's still very high level. It still provides you the flexibility of saying in China versus the US versus the EU versus India versus wherever you are, you can have different implementations of that high level requirement. But that itself provides an actual, something that looks more like a security control that can be inspected and looked at and see, am I meeting this control for this jurisdiction based on either NIST documentation or China's equivalent of NIST for the algorithms that they put out. Those are things that seem like I could actually do something with it rather than, because if you say, make sure the connection is confidential.
No, make
for
sure
example,
that this
let's say
particular
we're
data
in
item is confidential. That's not what I'm saying. It never says the connection is confidential. It says evidence needs to be kept confidential and attestation results need to be kept confidential. That's not what, that's not connection. And then the
that
auditor would
still
look at
doesn't
it and
still-
say, has it been written into a log in plain text somewhere? If so, you leaked it.
So
Now,
what
if
you're
you
telling me
have a
is you
better
require
way
an
of
auditor
saying
with
it,
the
that's
technical
fine, but then
knowledge
you
to know
basic.
that they have to check logs and network connections and being stored on disk and all these various different things, right? What is the auditor using as their guideline to determine the locations that they would have to check to determine whether or not the data is being confidentially kept?
Okay, so the way the auditor does this, usually there is a couple of different things. The first one is more like this. That would be a control specification. Control specification says, keep this confidential. And then there is a, and you can look at the CSA CCM, the Cloud Controls Matrix. There is a separate column in that spreadsheet that says implementation guidelines. And that is more detailed and say, for instance, you may be able to meet this control specification if you do the following several things. So somebody may decide to write their own implementation guidelines around this and say, the way you keep your evidence confidential is you never put it in a log in the plain text, or you use a secure channel, or then there can be a number of implementation guidelines for a particular environment.
So then the purpose of this isn't really to be actionable. It's to point to another guideline document for how
this is
be
to
actionable.
enable, the point of this is to be sufficiently comprehensive, covering the things that we the assets that need protecting, the properties that need to be delivered, while leaving it to an individual organization to figure out how they're going to go about delivering that. So this is more of a control specification document than an implementation guideline document.
So are you saying this is the document, if I'm going to design a set of security controls, this is the document I should look at to find out what my assets are and what potential attacks and
I
threats
would
there are
say
against the
so,
assets?
yes. That's keeping it at that level, yes. The implementation guidelines get hairy.
Yeah. Well,
And again, I appreciate you paying attention to that level of detail. This is a good discussion to have, but it's not necessarily obvious to people outside of the governance world of how this works. This is, in fact, maybe it's imperfect. We should find the imperfections and fix them. This is heads and shoulders above the kinds of things you will find in governance documents out there. But if if we can find, for instance, the initial thing that Osama brought up that says we actually need to ensure that the verifier is running the right code. That was like an immediate yes on my part, because okay, yeah, I'm not like there are many ways by which we could achieve that, but we should definitely ensure that there is strong governance over what code verifier runs.
I would say this one is as high level as that and as important as that. You could have an evidence being confidential and you could have still a broken solution. This governance document does not protect that.
Well, I do not say that you're going to ensure that the verifier runs the correct code via secure boot. And here I'm not going to say you're going to maintain confidentiality via secure channel and endpoint protection. That is the level of distinction I'm trying to draw here.
But
you
these
could
two
have a
are
high-level
two.
requirement that says you need to be able to provide some sort of verifiable chain that the system is in a state that you believe is to be okay. And if they happen to implement that via secure boot into a measured OS, into a confidential computer environment, that's technical details, right?
That's getting there. I do not know if verifiable chain is maybe going a little too far. I do not know. I could see it going either way, but that may be more of an implementation guideline to have some sort of a chain of custody. And again, like this, I do not know if there are like hard and fast rules, and we could decide to go the next sort of level down in elaboration. But I'm afraid that it might actually be somewhat counterproductive, because somebody may say, well, I have another way of doing it. And somebody else might say, well, I have yet another way. Or somebody say, that's kind of a risk I'm okay with. And Thomas, you've had your hand up for a while.
Right, yeah, so I forgot. But yeah, I just wanted to restate what Usama said in terms of spelling out explicitly the authentication properties on the verifier side, because otherwise the protocol is broken. And that's different from the confidentiality and integrity protection of the channel. It's really a different property that needs to be, that's another thing that you need.
Okay, so you're saying let's not talk about this as a requirement for confidentiality of evidence or attestation results, but more in terms of let's ensure that the attester is talking to the right verifier, much like we would ensure that we talk to the right certificate authority, for instance.
Yeah, exactly. Otherwise, you can interpose.
That one is a strong argument, because it's like I think I got too blindsided by the fact that we're talking about it in terms of confidentiality of a particular property, whereas here we're talking more around this is a highly trusted service, and the attester needs to know who to talk to.
Absolutely.
And that is a strong argument, and we can then formulate a high-level governance requirement around that. Keith?
I was going to change the subject slightly, so if there's any more on that conversation.
Well, okay, let me add something to the forces. We talked about confidential integrity, system of records, and I will add another one. Because it's a root of trust, I will add a comment saying, how does a tester know it's talking to the right verifier? So that one I can totally get behind.
Okay, so I did have to step away in the middle of this call for a little bit for an urgent matter. So feel free to just tell me this was already discussed. But a lot of these requirements that I'm seeing in the discussion are around that the tenant or multi-tenant, but there's not a clear definition of what is meant by tenant here and what their responsibility in the system is. Is that something you all discussed? If not, that would be great to be clarified.
Okay.
Because I like there's a number of things that I think would not be necessarily a consideration for a verifier, even if it is multi-tenant for what I am picturing as a tenant. So perhaps that could be when that gets clarified, it'll help me
Okay,
digest.
so we still have a couple of minutes left, and so I already added a comment here. So a discussion of what is a tenant. Can you put a little bit more meat on the bones of that? Okay, let's go to the next level deep. So what would you like to see as part of that discussion?
Sorry, I had remuted myself, but was talking. So a lot of the requirements down are around like isolation of tenants and having their own, like should have their own keys. But like depending on what the tenant is getting out of the service, I'm not sure like why that would be as strong as a should and a must on those, depending on what threat you are seeing and what security properties they are trying to achieve out of this system. As a tenant and what they would be concerned about not trusting other tenants for, and what kind of actions the tenants can be taking on this system.
Well, when we talk about tenant isolation, we generally mean that we have mutually distrustful entities that together utilize a service, right? And they would like to ensure that there is a sufficient level of isolation between them. So noisy neighbor would be one, but disclosure of information would be another. Like I wouldn't be able to change my neighbor's policies. That would not be bad. That would not be good.
Okay, so that assumes that there is a persistent configurable policies is part of the functionality they're getting out of this.
Correct. That's
okay.
sort of, I guess it's implied that each tenant has its own policy.
Let's not leave that implied, because I don't think that's necessarily a base functionality for a verifier. I don't think that has to be.
Okay, so I'm adding your comment here. We will take it up in GRC SIG and see how we can talk about that. Now, by the way, just to give you a little anecdote in the remaining minute, I did an analysis of our email systems at the bank. And in this case, you can think that a bank has like one tenant itself, right? Because 250,000 people using the email system. And then I realized that email consists of assets of widely varying sensitivity. So for instance, if I miss a spam email, the damage to me is 0. If I miss a meeting invite and miss a critical meeting with a customer, then the damage can be in the millions of dollars, right? And yet, one tenant. And it's sometimes important to think about your classes of customers and the expectations of each individual class. Now, there is probably a relationship here as well.
You're tying that into which part of the discussion?
Well, as you talk about tenant, we will probably need to talk about tenant in terms of a class of customers with a certain set of expectations.
Right. So, and then I guess as in the requirements down below, I guess what I'm really getting at is things that are around protection of their configured policies. Make that clear, like that if you there must be this protection around configured policies. Otherwise, it's not really clear what the musts and shoulds and things really apply to if there isn't those things.
Okay. So
then I
think
like for different types of customers, for different types of things like the kind of the profiles you were saying, then it all like you could map it in there very cleanly. But just let's not assume that they're all the same.
Yeah, perhaps a more clear definition of the various types of assets that the verifier has and discussion around what protections apply to each. We can definitely look into that. So thanks, Keith. And I think, Osama, I have to correct myself. This goes more towards, like you talked earlier about, more formal definition of what it is we have in this document. And perhaps there is some room for that.
I think the document is not formal at all.
Well, no, I don't think it's ever the desire to be formal. Like that is not the goal, but being a little bit more precise around the terms we use so that there's less ambiguity, that would not be bad. The formality is not the goal here, for sure. Okay, well, we're past the top of the hour, so
Yeah.
I have nothing else to say today, but we'll come back in a couple of weeks to this forum with an updated revision.
Yeah, thank you, Mark. I put that here as to continue discussion next week. But yeah, it was a really great discussion today. Appreciate it.
All right. Yeah, I appreciate everyone's input today. Thank you so much.
Yep. Hey, for the chairs, is the clerical, any volunteers for next meeting?
It's my turn, so put me down.
Okay, great. Thanks.
Thanks, Greg.
Hey, Mark, one quick question. Did you see my comment about other examples of governance docs to compare against in the chat?
Well, I would start with CSA CCM today.
CSA CCM?
Yeah,
Okay.
the Cloud Security Alliance Cloud Controls Matrix. It's actually being revised. There's going to be another revision, but I don't think it's going to be massively revised. And you can take a look at PCI DSS. That would be another one.
Okay.
All right.
Right,
Thanks,
thanks,
all.
everybody. Yep. Bye.
Bye.
Thanks,
So, have a
Mark.
good
Bye.
couple weeks.
Bye, guys.